try to understand this particular problem, which is related to Max Planck's quantum theory, which was put forward at around 1900 while explaining the radiation emitted or absorbed by black bodies. The question says, what is the number of photons of light with a wavelength of 4,000 picometer that provide 1 joule of energy? So you have to calculate the number of photons. How many photons together will make 1 joule of energy, provided the wavelength that is associated with the radiation, with the electromagnetic radiation, is 4,000 picometer. Pico is 10 to the power minus 12. So you need to understand the prefix. If you do not know the prefix, the pico, that it means 10 to the power minus 12, you cannot solve this problem. Yes, but the main idea is not understanding what Max Planck explained, how he explained the black body radiation, the radiation emitted when a body is heated, right? According to Max Planck, when a body is heated and when it cools down, the amount of energy when a body is heated, the amount of energy absorbed, or when it cools down and it becomes normal, the amount energy heat energy emitted, it emits electromagnetic radiation. It absorbs electromagnetic radiation, it emits electromagnetic radiation. So the amount of the energy absorbed or energy released by the body, it's not smooth. It is in chunks. It's in the form of the energy is quantized. It cannot have any value. It will have some value, or it will have multiple of some fixed amount of energy, right? So the photon, and that will be in the multiples of h into nu. It may be zero times this, twice once of this, two times of this, three times of this, four times of this. So electromagnetic, whenever a body emits radiation or absorbs radiation, it will absorb in the form of photon, that is called quantum, or it will emit in the form of photons, right? So the amount of energy present in one photon is dependent on the frequency of the light emitted, absorbed or emitted. So the amount of and it's proportional to the frequency. So when we convert that proportionality sign into is equal to, we add a constant, and that constant is Planck's constant. So the amount of energy in one photon is given by h into nu, right? Where h is the Planck's constant and nu is the frequency of the light or the electromagnetic radiation. So, but in our case, the question has not given us frequency, it has given us the wavelength. So what's the relationship between the wavelength and the frequency of an electromagnetic radiation? It's that velocity is equal to lambda into lambda multiplied by frequency. So frequency can be written in terms of the speed of the electromagnetic radiation, and wavelength. Instead of writing frequency, it will be c upon lambda. So the frequency is c upon lambda, and c is what's the velocity of the electromagnetic radiation, which is nothing but that we have learned from a very young age. The speed of light in a vacuum, 3 into 10 to the power 8 meter per second. The value of Planck's constant is 6.626 into 10 to the power minus 34 joule second. And the wavelength, now you're given the wavelength. So wavelength is 4,000 picometer. Pico is 10 to the minus 12, converting into meter. So simplifying it, I just took this as a 7, as a whole number. So 7 multiplied by 3 is 21. 20 by 1 by 4 is around approximately 5. And simplifying the powers of 10, it becomes 10 to the power minus 17 joules. This is a very small amount of energy, right? 10 to the power minus 17 joules. And this much energy is present in one photon uh, of any source which is emitting a wavelength of 4,000 picometer. Each photon of it will contain this much of energy, right? It's a very small energy. So now what we need to find is how many photons of this together will become one will make 1 joule of energy. So it will be just a unitary method. This much energy. This oh, okay, sorry. 10 to the power minus 17 joule means one photon. So 1 joule means this divided by 5 into 10 to the power minus 17. So it's around 2 into 10 to the power 16 photons. So 2 multiplied by 10 to the power 16 photons will make up 1 joule of energy. And 1 joule of energy provided the wavelength of the light of the electromagnetic radiation is 4,000 picometer. I hope that it brings some clarity.